So now if you want a 204 to be way over spine, you end up with a wall thickness that you cannot control. Then people say, well, if 204 is based on the marketing scheme that everybody is using, if you think 204 is great, 166 must be wonderful, right? No, 166 is worse.
Hey, what's going on, everyone? Welcome back to another episode of the Deer Gear Podcast. It's been a little while, but I am back with Dorge from Firenock and Jeremy Martin from X-Ring Custom Arrows. The long-anticipated wait of the 204-166 insert conversation is finally over, and we have it here today for you. So we're covering inserts for your 204 and 166 arrows, which are actually either half outs or outserts. So it's a really good conversation. We cover different material properties, what different materials will do for you in an insert, strength, weight, things such as that. Real quick, before we get fully into this conversation with Dorge and Jeremy, we do have one really cool announcement. Exodus has a trade up program for the entire month of March. So if you have an Exodus camera, maybe you have an Exodus Lift 2, or you have the original Exodus Lift or an Exodus Trek that is either out of warranty or it works just fine, but you want to get in the cell camera game, we have a trade-up program going on right now where you can save $100 on an Exodus Render or Exodus Render bundle. Go to the website, ExodusOutdoorGear.com, make a purchase on the website. In checkout, use code TRADEUP, all caps, one word, trade up, and you can save $100 off an Exodus Render. Now, how it works is you make the purchase. When you make the purchase, we will send you a return label. Once we get your old camera back, we will then send out the new Exodus Render. So if that interests you guys, make sure you head over to the website. But for now, let's get into today's episode. All right, everyone, we're back at the Great American Outdoor Show. This is podcast number 2 from me and Dorge and Jeremy. Thank you guys for coming into the show a little early. I'm on time today.
Very welcome.
So last conversation we had, we were talking about inserts, and we kind of focused on the 246 shafts and 300 shafts. And today we're going to be moving on to what most people are probably most interested in, because that's probably going to relate more, because most people are shooting 204 outer diameter shafts or 166 shafts. So we're going to talk about those inserts today, correct?
Yeah, absolutely. But before we start, I saw a lot of guy people into thinking of inserts, because a lot of people really don't think much about inserts, because they usually buy a dozen arrow, then they got whatever insert they get to. But the fact is that in technically every single size of Firenock, on every single identical shape, we also got different material. And people say, why do you make different materials? I want you to think your broadhead and field points as nails, and your insert material as the material of hammers. Because you can have the same shape of hammer with different weight. That's the reason we in Firenock, actually in most cases, we use 5 different material, actually 6. The first material we use is of course the basic 6061. But we only offer that material through our dealers, through our certified and trained programs. But all aluminum that we sell straight on websites are actually 7071s. The reason we use 7071 because 7071, it behaves like an insert, is although it's the same weight as a 6061, but you got 82% strength of hardness. That means you don't have the weight, but you have the strength. But then the next thing we original offer is the 303 stainless. 303 stainless is great because it got mass, but it doesn't have strength like 420 stainless. That's the reason when you go into like our more like the 204, 166, that kind of UC stainless, it will be 420 hardened to at least 50 HRC. Then for the people who want ultimate, which is strength and weight balance, we will offer the titanium. But then for people who just like the weight, but do not want to pay the price of stainless, we do offer brass through our certified dealers. So now when you think of why in some cases we offer 5 material in one size, the reason for that because strength and weight and price. So when you look at it, say why so much? Because that is the reason behind it. And a lot. Now think about it. You're holding an 18-ounce hammer. If you move on one material to the other material, the hammer can be half the size. The mass is a lot more focused. When you use a thinner material, you're doing a more precise tapping. They will be the same size, and which is exactly where we start with the 204. Like Jeremy was one of my best 204 166 builder. The 204 alone, we offer 6 different inserts in 7071, in 420 stainless, and in GL5 titanium. Yes, there's 3 of them in same material, but we also offer that in lightweight aero concept and heavyweight aero concept, all without aero concept. That itself would technically give you 9 different inserts, but it's just not 9, because in the lightweight and heavyweight tubing, when you get good at it, you can use vacuum tubing to glue as long as the tube you want. Imagine if you're dealing with a 29-inch aero, you technically can put in a 12-inch tubing in the front. Then you can now just change it. Well, with your experience, take it away.
So let's hammer one thing out here with the. We talked about the 6061 and the brass. Make that clear that is not a 204 product or a 166 product. Like Dorge said, we're a titanium, the 7000 series aluminum and stainless, or titanium rather. Very good products. I don't do the 12-inch vacuum. We do a lot of Aero Concept 1.0s. We just took an order last night for some titanium stuff out of the Aero Weave. Flawless performing Aero when it comes down to it. And if you have any questions, please, because I run out of stuff real quick.
No, not a
I
problem.
keep it simple.
Sure. Yes. But you see, I mean, in the 204, a lot of people don't understand when you deal with 204, you have to deal with a design called half-out. It has to be a half-out, and people say, why not put an outsert? Now, we need to look at the original specification of the AMO, which now become the ATA standard. You're dealing with a shank of a fill point that is actually 202 to 204 thousandths in OD, which means that you must put it inside something that is 204 or 206. In the case, of course, with us at Firenock, we use our dual O-ring system. That's the reason we always compress 4,000 around it. So it's either 202 or 204, our arrow point will always go in perfectly. But then you're dealing with the inner tube that is 202 to 204, or maybe even 205. I know some company who's not very tight on the spec, the idea of the shaft is even up to 207. Now, that's the case, when you glue an insert in it, now in the case of the 204, you need to think about it. If the tube is 204 and the shank of the fill point is 204, there's only two ways to do it. You either embed half of the broadhead and the shank inside, or you simply, like Easton did, Easton with the HIT insert, simply take the shank away and use the shank to go into the tubing and put what you call an HIT insert. That approach seems great, and only one company overcome the major problem with it. Actually, there's 3 folds of problem with that design. Think about it. The tube is 204. Your insert has to be smaller, right? The moment you put the epoxy, then you use a tool to push that piece in, and you let it sit on the table. What does that mean?
Just goes to the bottom.
Exactly. You are guaranteed 2,000 off center right at that moment. But that's not just the first problem. The second problem is that imagine all your epoxy is flowing down towards the insert. Now you got a weak non-concentric issue. But the fact is that, can you overcome this problem if you really want to use that design? Then you need 3 things. The first thing you do is that you need to get yourself an old fill point, and you put some wax or Vaseline on the shank. Then you put the insert onto the tube. Then you put the epoxy on it, and you push the fill point down all the way, and then stand the arrow straight. But before you do that, you need to hold the fill point and you roll the shaft to hydroflow the glue. Under that condition, you indeed can make the heat insert work. But then the second problem is that, remember, carbon is strong, but carbon cannot handle impact. So every time when you shoot a target, that's hard. the back of the field point is going to crush the carbon. Now, I'm not the first one who would recognize it, and this credit belongs to NAP. When Eastern first come out with the heat insert back in 2004, NAP instantly recognized it. They make you a bushing. It's a bushing that go behind the field point and covers the shaft. That somewhat prevented the shaft from crumbling, which is really good. But then the fact is that when that piece come in, it never really sit well with the broadhead because we cannot guarantee the shaft in the front is always perfectly squared. I mean, you got squaring tool, you got that piece, yes, it worked. But then you pretty much have to constantly move it lower and lower because the carbon eventually will be crushed. That's not enough solidity connection between the piece of bushing and the shaft. Which brings to the next one. Say people, why can't I use an outsert in this situation at 204? Won't it be better? The fact is that an outsert, when you look at it, if you put an outsert in a 204, and inside that is a shank, how much material do you need to fill that space?
With like epoxy or...
Not just that. If you use aluminum to fill that space, it's become impossible. Remember, you're dealing with an outsert. Mm-hmm. The outsert is already, that means that's void for where the shank goes on into. It's a huge space.
Weak point.
It becomes your weakest link. Now, unless you say, I don't care, I just want to put a gigantic outsert, it'll be 2,000-3,000 over. Yes, but then you're dealing with humongous weight. But then you also deal with a secondary problem. Now you put some OD that's significantly bigger than the shaft. You're technically impossible to put it out of target now.
Yeah.
That's the reason outsert, and people say, oh, I can put a insert in it and put a, say, sleeve on it. Well, you pretty much screwed up the entire aerodynamics, ARROW dynamics, because the flex of the shaft now is now restrained by the collar. And not to mention, you also got a humongous amount of weight in front. That also complicated your aerodynamic calculation. So that's the reason, after all this thinking process, I was very lucky to sort of see other people's problem because I come in late from anybody. Mm-hmm. So we make something called a half-out. But our half-out is, Jeremy will tell you, our half-out are not like ordinary half-out. It utilize our original reverse taper systems. But unfortunately, a lot of our customers really do not understand how to install insert in the 204 class. Yes, I say 204 class. Because if you really look at it, 204, depends on which company you deal with, it's not one size. The smallest 204 is a 201,000, which come from the company called Fat Shaft out of Carbon Impact, which is why when you try to put your arrow deeper, you couldn't because it's a 201 there. Then you go to basically your 202, the 203 should be 204, but then some company make all the way to 207. Now, we make our insert originally to meet everybody's need. We make our insert on the part you glue into the shaft 201,000. That actually creates a lot of problems. I want to point that out. Is that we prevented all the problem. The problem is that people do not know how to use it. I mean, Jerry will tell you, if I just gift it to some customer, they go ahead and glue the insert, then they lay the insert on the table. Now you got a real problem because see, the OD of a 204 class arrow vary between 5 all the way to maybe closer to 7.5 millimeter. The frontal part of our 204 is 8 millimeter. The moment you put it together and you lay it on the table, that insert is guaranteed to cockeyed. So what you need to do is that you need to glue the stuff with a slow set epoxy, float it around, and wait 15 minutes. Hold the insert and roll the tube. You hydroflow it, then you send it straight. But then we say, well, how do I know it is reasonably concentric? That's where our reverse taper, in other words, our mating system between the shaft and the insert comes in. So if you really hydroflow your shaft, even if our insert is 201,000, you hydroflow it, you're forcing the epoxy, which is high viscosity, with a high CP rate. It will instantly flow around it. It will self-concentrate. But now the next thing is that you do not just lay it on the table. You send it straight on the ground.
How many people actually do that?
More than you can imagine. To the point that because we sell so many basic 204 reverse taper insert in the A class, which is the AIA 204, in stainless, a lot of customers do not understand our shank is 201, and they start putting it in, say, gold tip or element, which is one of the biggest. If you go ahead and just glue it and sit on the table, your insert now, in the case of element, you have 5,000 cocked based on the 1 inch space. With that space equivalent to about 4 degrees. Just think about it. Your insert now is 4 degrees off center.
So what downrange, what effect does that have on your arrow?
You won't be able to shoot it right because the entire insert is now crooked from the shaft. That is one of the most important. I mean, even if your shaft is not straight, but your insert to your shaft have to be absolutely straight, because that is the leading and the controlling factor of the entire arrow. When you add weight, that's where your controller is. When people talk about front and center, in the case of recurve, that is what the leading piece is, which is technically that's your steering.
Yep.
So you can now. What happened in 2021? That happened so much because a lot of customers did not go to archery dealers. They bought the 204 stainless from us, and they have this problem. So I'm very lucky to tell you guys, as of 2022, just to make everybody happy, I make 2 204 stainless. One is go from 2001 to 2003. The one to go from 2003, 4 to 2007. So when you fit with it, the maximum variance you're dealing with is 2,000 on each side, compared to a possibility of 7,000.
Yeah, 7. Yeah.
I mean, those are the things we deal with. But unfortunately, we publish all this information about our insert. Of course, Jeremy went through the Certified and Trained Dealers program. He do it automatically.
Yeah.
But when a customer first time try to put this together, glue the insert, get the element, put our insert in the front, put it down, lay it on the table. Next morning, look at it. Every one of them look like this. No, I'm not joking.
Yeah.
At that moment, it's not funny because you just pay so much money for the shaft. You pay $40 for my insert, and everyone looks like shit.
Yeah.
And there's no other way to say it. I mean, it's not that bad in aluminum. It's not that bad in titanium because they are reasonable lightweight. And then when you look at it, you can easily work with, and they don't have such effect like stainless steel, which have a lot more mass.
Sure.
And most people buy titanium, since it's so expensive, they spend the time to read. The most people do aluminum, which is reasonably lightweight. When you lay on the table, it's not that bad. But the stainless is really horrible. Not because the design is horrible, because people didn't really recognize what they're doing.
Sure.
That's just on a 204. But then the moment you go to Aero Concept, which is this guy here is my #1 builder for 204 shaft. He just built wonderful 204. Just like yesterday, I saw one of my oldest customer, which I met since 2009. And he said, you need arrows. I said, I know exactly who you go to build it.
So what kind of questions can you come up with that maybe a 204 customer may have, regardless of brand? Just any kinds of questions.
Yeah, the easiest thing that most people who love the 204 is that they went through. The funny thing is that 2021 is the year that 204 come back like a gangbuster. Because 2019 and 2020, a lot of people go to 166.
Right.
But those are the high-end customer because they are one who forward.
Sure.
I will tell you, within 2 years, everybody will go back to 246 if they know what they're doing.
Right.
Because they have such hard time with 166 and 204.
What makes 204 shafts so much harder to build to get them correct?
No. 204 is not. 166 is. Because this 204 compared to 246 is the thicker wall. And you are dealing with a half out.
Yep.
And people don't understand what a half out is.
Sure.
A half out means that half if you're broadhead, half of it stay with the insert on the outside, and half of it, which is shank, your thread, is actually staying inside the shaft, inside your carbon, and inside your insert. When you do something like this, the weakest link in this thing theoretically is between the carbon and the insert. But if you design it correctly, that point in our case, in Firenock case, is strongest because you got the stainless steel, you got the carbon, and you got the shank, all concentric each other. Do you truly have a weakest link? Yes, you do, which theoretically is when the carbon met the insert. But in our case, we got reverse tapered. That means if there's any angle force, the reverse taper will divert the energy into the shaft.
Fit together.
Correct. Now they say you set a secondary weakest link. The secondary weakest link will be just the space right behind the insert into the carbon.
Okay.
If anybody break an arrow, that's the spot. But then in our cases of arrow and Firenock, it's really no longer the case because we got secondary carbon tubing that extend the entire thing further. We say, well, we break behind the carbon tubing? Answer is no. Why? Because the carbon tubing flex with the shaft. It mitigates the entire directional force on it. Now you understand why the arrow concept is so good. But at the same time, a lot of people say, why can't I put 50 grain in the front, 125 grain, 150 grain field point or broadhead? Didn't I got a fantastic penetration? Answer is no. The penetration actually go down significantly. Unless you got a broadhead, that's like something like the Rage hypodermic, or something like the old Hawk broadhead, which is a long tip before you see blade. Because when you go into a high LFC 204, especially from 204 and down, we're dealing with an arrow just like we're talking in the shaft. The wall thickness is significantly higher, which means that the energy, the flex retaining memory is higher. Which means that if you're at short range, you hit the animal, your tip of your arrow are still flexing. That means the angle of impact is no longer direct. I mean, just like anybody who attests, I tell people, if you doubt this, do this experiment yourself. Get yourself a nice tomato, get your sharpest knife, hold it on top. Don't roll it, just straight cut it down. So get a feel of how much force that is. Now turn the tomato to the other side. Give it 3 degrees off center. Push it down the same. You'll find out you need 30 to 50% more power just to cut it.
Sure.
Which means that if your arrow is not straight when it hits your target, you have to use over 30% more power just to penetrate. Now the insert come into play in a big way. Remember, we say that imagine your field point or your broadhead is your nail. Your insert is your hammer. Your shaft is your handle. How would you like your insert to work? People say, oh, the bigger the hammer, the better. Is it really true? You are not framing now. You are not doing trying to break concrete. You have to be optimum.
Yeah.
See, I think in archery, one of the biggest issues is that people say, oh, I just want, just like so many customers, give me your best. To be frank with you, all 6 or 9 of our inserts in a 204 are the best. Every one of them.
Things.
The only thing is how are you going to apply it? Now imagine if you want to build an arrow that's about 370 grain. Right on the get-go, you cannot use stainless.
Yep, too heavy.
Yes, because the people who want a lighter insert, especially in a 204 class, you want the arrow to fly to recover as fast as possible. Lightweight front is critical. You can't possibly use stainless. But then you want some weight in it, especially dealing with bigger animal. Yes, the moment you deal with bigger animal, momentum is critical. But it's not just momentum on the insert, not momentum on the field point or a broadhead. You need to add the momentum to the shaft. The beautiful thing about an arrow shaft is that you need to think of an arrow shaft not like a bullet, but like a train. Because if you can make the entire thing move forward, the force is continuous as a whole. When you use heavy FOC, the train part is a reverse process. You actually pull your arrow backwards. Think about it. If you flex left and right significantly, what would that mean? The resulting factor is backwards. That is where the problem is. A lot of people do not really understand how important the shaft it is for it. Otherwise, we'll be throwing bullets, not arrows. Arrow shaft itself is not just as simple as transferring energy to the shaft. It also has to maintain and actually move the entire process onto the target. And that's the reason a heavier shaft in so many ways are much better.
Heavier shaft as opposed to heavy broadhead.
Correct.
Heavy field. Yeah.
Now then, why do people like lightweight shaft? That is application of lightweight shaft is absolutely needed. Imagine this. You got a gentleman that's a 26-inch short, 45 maximum pull. If you give him a heavy shaft, what do you think his pin gap is going to look like?
Oh, yeah, it's going to be...
Right. If you want to shoot 60 yards, that's not enough tape. That is not enough pins to do that. So, and a lot of people don't understand it. Just like we have a lot of challenge to do that. Now we sort of like get into the details of why we make two different 204 size insert in the aero concept. Because I also understand the moment when Eastern was doing all the testing, like for the Access Dangerous game, they keep on increasing shaft weight, but they did not increase the insert weight. Mm-hmm. Yes, lately you see them have brass and stainless steel insert for the HIT, but that's only limited to so much. Mm-hmm. Because the longer the HIT insert you have, remember every time you put a HIT insert, your node of your shaft is right behind the insert. In other words, you don't put your aero rest on the front. You need to know where your insert ends and add an inch to it. That's where your true your pivot point, which is the node your arrow is. Then we also have to think into it, okay, all this. But if I really want to say using a dangerous game for, say, an elephant, and now I'm looking at 250 grain broadheads, right? You do a 450 grain broadhead, you put, say, a 50 grain insert. There is no shaft out there that will give you 130 spine for the application. But now we are finally able to give you the answer. Because our 204 heavy inner tube, it literally changed with our this application. I will use the 204 heavy, which is our 420 or 304 stainless, with our heavyweight, which is 8.1 grain per inch. You put 6 inch in it, that's 50 grains of tubing. Then you add 50 grain of insert. Now there's 100 grain. But that's not just that. You actually with such a heavy inner tube. That tube alone is a 350 spine tube. Mm-hmm. Now you put it in, say, a dangerous game, 250 spine. The effective of that third, assuming that you're 29-inch draw, okay? This time you can go ahead and minus 6 inch because of arrow concept. Yep. Your effective length of that specific arrow is only 23 inch in flex. At 23 inch on that spec, over a 20x span, you are now at 130 spine now. I mean, you see how beautiful this whole thing gets? Of course, if the person that is really good, like one of my best builder, Jeremy, was able to do, he will even do Aero Concept 2.0. He put another 6 inch on the back. Now, your 29-inch arrow effectively minus 12 inches in effective slack. You are dealing with, 29 minus 12, you're looking at a 17-inch arrow effective. I mean, yes, this is not meant for a 50-yard shot. If you are shooting elephant at 50 yards, yeah, you're a much better man than any big game hunter I ever know. Think feet, don't think yards.
So, Cameron, do you have any questions on
Did
the
your
204?
customer ask you anything on the 204?
Not yet. We haven't really talked about the 204s that in depth yet to have a bunch of feedback. But myself, I'm just trying to understand, like, everybody is shooting 204 or 166, and Dorge says 246 is the best or 300 is the best. What are people missing that they can't understand that?
Well, the thing is, first of all, you can see the complication of how to put a 204 accurately. But then the fact is that when you think that we're holding a thinner piece of arrow and the marketing telling you, this is the best. Now the question, nobody asks why.
Sure.
Then they say, oh, let me shoot this 204 into target compared to 246. Look at how much more it penetrates. Obviously it does, because everybody testing using field point that matches the size of the diameter. It is thinner. But then when you throw a broader on it, the cutting is identical.
Sure.
Just people need to understand, no matter what spine or diameter shaft you use, the end of the day, you have the same amount of carbon to give you the spine.
Yeah.
So the only thing you gain in most cases, yes, the thicker the wall, the more durability you get. Wind drift have zero effect in shaft. As a matter of fact, when we were doing vane testing, we proved to that a 2764 and a 166 identically without vane fly identically up to 130 yards. But the moment you put vanes on it, it's the vane that is the problem, not the size of the diameter.
So why shoot vanes? So why shoot vanes at that
No,
point?
no. That vane can be a 2 or 3 episode deal. We're talking pure aerodynamics, AERO and AROW. Those two dynamic is very involved. The moment you go into those environments, the shaft dynamics, the insert dynamics, all become part of it. This reason I delay talking about vanes.
Sure.
At least we finish inserts.
Sure.
Because until you understand, you don't even know how detrimental and beneficiary, those are two extreme a vane can do. That's the reason I delay it. But then you think about it. If that's the case, the thicker the wall, the more durable a shaft, but the less performance it get.
The harder it is to flex.
Correct. The flexing of a shaft and how fast to recover. That's the reason a lot of people say, just like I'll quote Goldtip Tim Gillingham, you can never shoot an arrow that's overspined and be bad. The only thing bad about it is weight. So now if you want a 204 to be way overspined, you end up with a wall thickness that you cannot control. Then people say, well, if 204 is based on the marketing scheme that everybody is using, if you think 204 is great, 166 must be wonderful, right? No, 166 is worse.
Which is what everyone's shooting.
So,
no, not everyone.
Without all the scientific terminology, you have a 166 shaft that is a 350 spine across the board for 166, a 204, 246, and a 300. If you were to get all three of those shafts and look down the shaft before anything was installed in them, you would see the 166 shaft would be significantly wall thickness thicker. 204 is a little smaller, 246 even smaller, 300 even smaller than that. So think about it like what it takes to calm that arrow down. How much more energy is going to be consumed by a 166 shaft versus a 300 shaft. So you'll have a lot more energy retention in the 300 series shaft or the 23 series, whatever you want to call it, compared to the 166. But like Dorge was saying, the 166 is more durable because you've got 3 times the wall thickness versus the 300. But performance-wise, the 246 and the 300, which the only people that even look at a 300 shaft is a crossbow guy.
Yeah.
You know, me as a vertical bow hunter, you say, I'm going to give you a PS-23 to go hunting with.
Yeah, right.
People are going to look at you like you're crazy.
Yeah.
But if you think about it, performance-wise, strictly on performance, your arrow is going to retain, I don't know the percentage number. I'm sure Dorge can fire that out at us. But it's significantly higher than the 166.
Okay, so on a durability standpoint, I think a lot of the reasons why this shorter or smaller, thinner diameter shaft on a durability standpoint is everyone's talking about penetrating bone. Mm-hmm. And the moment you hit bone with a 246 or a 300, do you face more issues than with a 166 or a 204?
Actually,
is it not going to hold up to that?
That is where the misconception is. When you're dealing with a 166, when you hit bone, it actually penetrate less because you're dealing with a shaft that is not straight. Mm-hmm. Because you have more memory retaining. That means when the arrow actually hit the bone, the arrow is not straight. The back of the arrow are still flexing. People need to understand on a 246 or 300, the arrow, based on the 65% off, okay, the arrow recovered at 18 yards.
Yep.
On the 166, it takes up to 23 yards to recover.
Without
without anything.
Yeah. Yep.
Without any arrow concept or chamfering tools or anything. You need to think about it. In North America, most people shot the animal in 20 yards. Mm-hmm. Okay? If you shoot a 246 300, the arrow is straight for 4 yards.
Yep.
You shoot a 204 to 300, the arrow just becomes straight. In the 166, the arrow can still be flexing. Just like I talked about tomato issue, the test. At 20 yards, you shoot an animal with a 166 with a single bevel. You now have to hope that your blade is impacting the animal perpendicularly, not when it's still flexing.
Yep.
But even if it's not flexing, the rear of the shaft is still flexing. Mm-hmm. It is like, imagine yourself, try to hit a hammer when the hammer is vibrating when you hit it.
Yeah.
At an angle.
Yeah.
When you start thinking about it, it's become detrimental to the entire hunting process. How can you prevent it? I mean, the fact is that the only way to overcome a 166 class arrow is to make the arrow's frontal part of the arrow straight as fast as possible. And second, lower the weight of the front of center.
Which is what the opposite of what
Well,
everyone's
but
doing.
Exactly.
Yeah.
Yes.
But the fact is that if you understand physics or talk to any physics professor, and I tell them what you're doing, they would, first of all, they explain two things. They will explain the tube dynamics. Second, they will explain to you harmonics. The moment that two things come by, and finally, your impact angle. If you understand that three, it's laughable. You simply want a heavy FOC on a thin arrow. I mean, very simple. Let's say if you've got a tube that's 30-inch long, you hold it on the ground, you try to hammer it. The larger the diameter, the more it goes in. Not small. As long as you got a good tip. Remember, no matter how big or how small it's the size of the arrow, the tip is the same broadhead.
Yeah, right.
So when you hammer that thing down, if you hammer a big tube, the tube is going to give you the structural integrity to go down. The moment you got a thin tube, the thin tube is going to wave. Even they are identical in weight and identical in strength. That's where the tube dynamics come into play. The larger the size, the faster recover, the higher the performance. The thinner the wall will match the thick wall in performance. In the case of arrow, you notice that as you decrease the arrow size in diameter, the weight is about the same. You know why? Because you got the same amount. If you buy the same class of arrow, like your 32-ton, your 24-ton, your 38-ton modulation carbon, I'm talking about carbon grade. If it's the same grade of arrow in use different tube, you notice they have to be of the same amount of carbon in it. Because what you're dealing with is the true spine of the shaft. When you got a 300 spine shaft, that you may be a slight variation is the inner skim and outer skim of a carbon tube. Now then, when we move into the 166, as we say, all this problem now compound. How do you overcome it? Think about it. In the 166, the only thing you can put inside that shaft is the thread of your broadhead based on the AMO standard. That means the OD, the ID, the outside diameter of your shank is actually 167 millimeters, 167 thousandths of an inch.
It's wider than the...
So that the moment you put that broadhead into your arrow, the field point or the thread will stop the moment you hit the shoulder. So that's how much you can put inside. Now, think about it. If you want to use an insert based on AMO standard, you can't possibly put the thread inside the shaft. So now the thread had to be above the shank. Now, when you do that, which means that from the counting point, which is the tip of your field point, to your neck of your field point, to the bottom of the thread of the field point, plus material transition, is in front of the carbon arrow.
Yep.
Then to make it good, you now have to add the behind part, whatever's inside the shaft. That whole thing become your effective length of your broadhead or field point. Where's your node? Your node is 1 inch behind the inside of that.
Yeah.
The longer you get, the worse the arrow will fly. Because think about it, your node is your pivot point of the arrow shaft. The longer it increases, the more this will swing. See that, the difference? Now you tell me this is better compared to this?
Yeah, no, yeah.
That's also the main reason we find out when Black Eagle first come out with that deep impact, they don't have an insert, so they call me and say, hey, Dorge, we need an insert system for our deep impact. I said, sure, I got a design. I give them the outsert. But the outsert say, this similar designs come out since the days of the Beemans. Because the Beeman extruded arrow, the ID of the Beeman is not even 166, it's 110. So they instantly, they go and put an outsert on it. But outsert have a whole set of problems. If your outsert thread is above the arrow shaft, that's a misconnect between the bottom of your arrow shaft and the top of your arrow shaft and also the inside of your field point. If you, as I say, if you use a pure outsert process, half our process, that means you got a chunk outside the arrow shaft, a chunk inside the arrow shaft. Your entire field point from top to bottom is above the arrow shaft. Which I do one step better. What Beeman did is that I designed an outsert that the thread of the outsert is only 7 millimeter, which means on a 10 millimeter. On a typical screw shank is 15 millimeters, which means that if you think about it, You got your broad, you got your field point, then you got your field point shank, which you know is above the point. Then you got your thread. Then after the thread, that is extra of the thread because the threading part is only 10 millimeter. So if you got a shank that's 15, I will allow at least 5 millimeter of that shank be inside the 166. Now the weakest link becomes the strongest link. But then we also go into the fact is that if you're old enough like me who shoot Beemans, the moment you shot the arrow into meat, you better grab your knife out because you need to follow the arrow and cut through the meat to get your arrow back out.
Yeah.
Because you got a wedging effect now. That's the reason if you look at the Firenock called the outsert, it got grooves on it. Those grooves are sharp between the edges. Those are actually called blood channels. It's the same as a potato knife. You notice when you cut potato, it stick to both sides? Mm-hmm. But when you put slots on it, it go down and you just fall off.
Yeah.
Because you allow air to pass through. That's exactly what those are. Those are blood channel or potato channel, which you want to call. I think blood channel is a sexier term.
Yeah.
But then we also have to deal with the fact is that when you deal with an outsert, it is not like an insert. You only have to deal with ID. Say a 204 class, I make one size fit all. But in the case of outsert, we have to make 16 of them at this moment.
Wow.
To cover the entire spectrum. And people don't understand, when you deal with an outsert, you're dealing with the OD of a shaft. All the 166 are made through centerless grind. That means you have you sort of have a mandrel, then you put carbon on top, then you put it through a 3-ray grinder to get to the weight you want, not the size, the weight. Because the weight is equal to the spine in the case of carbon. That's how most people do it. One thing that people don't understand, they need to look at the shaft. Most of the 166 shafts are not concentric. The grinding process is outside in. It's not holding the insert and grind the outside. So that's the reason if you take a closer look at 166 before you do it, the wall thickness on all sides is elliptical. That means if you put an insert in it, you're off-center to be guaranteed.
Yeah, it's not going to be.
Yes. That is reason an outsert on a half out on a 166 is so bad. Then even I put a reverse taper on it, it just exaggerates the problem. Mm-hmm. Because now the reverse taper have one side more, the other side less. The more you hit it, it will crook by itself. That's the reason you need to move to a true outsert. The outsert is a pretty decent approach to it. But there's a lot of downside. And most important, the reason the people always call me, do you make an outsert that is 50 to 100 grain? I say no. Because the whole idea, you understand how to shoot a 166, you understand you want to lower the front weight as much as you possibly could. And the only way I can make it strong, because originally I was thinking of titanium. The titanium is stupid. Because the titanium in this shank, I don't care you make a GL5, that's not enough strength. The only way to make this is using girt, that means diameter. That's the reason our 166 OD is 8 millimeter. Now you got 2 millimeter all the way down, then you taper it. Now you got girt. See, when you deal with mechanical science, girt is one of your best friends. Until you hit the certain weight limit, when you fly, then it's your enemy. But everything in size is always better. I mean, it sounds ridiculous, but that is the truth. Anytime you do an insert, outsert, free point, the larger the diameter you got, the better you get.
So what are some of the downsides to the outsert system?
Well, first of all, you have the specific one. That means if you buy a shaft, you need to be as specific as you can to the OD and ID match. And then, as I say, they are centerless grind, which means that when you buy a dozen arrow, if it fit 8 of your arrow perfectly, you guarantee not to fit the rest of the 4. Then you need to use something like 100 and 200 sandpaper to stick some of the carbon out, to put it on. And then remember, when you're dealing with an outsert, you are gluing the inside surface to a tube, right? How do you guarantee the inside of that tube able to hold your glue perfectly? You cannot. That's the reason I got a whole video to teach people, hey, when you're dealing with outsert, you want to scratch the inside outsert to expose some aluminum. Because if they anodize the whole thing, but can you not anodize it? Answer is absolutely not. Because you're dealing with blood. The blood will screw up 70, 71. Let me step back. Unlike others, I do not use 60, 61 T6 for my outsets. My outsets are 70, 71 T6, not T5. Do you know why it's from T5 to T6?
Well, what's the difference between T5 and T6?
The higher the T, the stronger the material.
Okay.
When I bought the 7071 T5 to make the outserts, I put it inside the mold, and then induction heat it and strike it. That moment, the process of striking it, I realign the molecules.
Okay.
That process of striking, it changed it from T5 to T6.
Oh, wow.
So now instead of 82% stringless, it's closer to 88% stringless of a 303. But then the weight between aluminum and stainless steel is a 1:5 ratio.
Okay.
And stainless steel to, I'm talking general stainless. I mean 303 is much heavier than 420. But I'm talking general stainless. I'm using 303 as standard, and aluminum are using 66 as standard. Titanium is going to be 45% lighter than stainless, and aluminum is going to 1/5 the weight of stainless. I say, if I want super lightweight, what are the possibilities? Answer is magnesium. Can I do it? Yes, but I just don't think people know how to work with it. Because magnesium is about close to 35% lighter than the aluminum.
Wow, that's light.
That is, and still have structural. But then the coating, the finish, but remember, when you expose aluminum to water, it will burn and burst.
Yeah.
Now you need to know what you're working with. Now let's go back to the 166. Outsert is such a good system. But then we also face the same problem. How the hell do we make the arrow recover faster using 166, which we know we got memory and straight?
Before we go any further, get it out there that the Firenock outsert is aluminum.
Correct.
And there is only one weight. Well, it's a varying weight depending on your size, from 30 to
32.
33 grains.
Yes,
max.
no, 32 max.
Okay.
Because the larger the diameter of the shaft, that means the less the material on
Sure.
it. Because we only make one mold.
Yeah.
After that, we drill the size that you put the shaft in. Then we machine the tail. That's how we make them. So they are all same as 32 grain because that's how much it is. Then we machine the tail off. Mm-hmm. So when you machine the 577, which is the big, smaller shaft, it is the heaviest. Of course, on the 568 is 32.1 grain, which I call it 32. When you deal with, the 680, the larger diameter, that one is exactly 30 grains, which now give you that 32, the 2.1 grain difference. But then your lot, because you don't buy some 6.8 millimeter, some 5.7 or 5.68 millimeter, the lot that you got is the same. But then you need to sort of send the odd size shaft you have. The idea is that people say, oh, I want to make the shaft tight fit. No, you do not want a tight fit. You want it fit enough that you can barely spin it. You know why? Because if you make it totally tight fit, where is the glue going to be?
Sure, yeah.
There's no glue.
Yeah.
The moment you shot it, the insert's going to be inside your target.
Yeah.
And at the same time, again, we're dealing with the same thing. We're talking two tubes concentric to each other. The only way to make an outsert correctly is that after you put the glue in, you need to hold the insert solid and you spin the tube. The easiest way, I did have a video show people, use our APS system. You put the arrow on the spinner, you hold the shaft, and you spin the arrow. Now you hydro flow the glue. Mm-hmm. You're guaranteed to concentrate. Then you stand it straight up. Don't lay it down on the table. Now we talk about how 166 is such bad in recovery. One of my customers in Minnesota called me and said, hey, Dorge, I read everything you have. Won't it be smart if you put your 166 tubing inside that? Because I make the 166 tubing for one reason only. It's for the target guys to put the fuel point in to recover the arrow faster. He said, wouldn't I put a 166 tubing inside your CTI 160, inside your 166, behind your outsert where the fuel point goes? I said, absolutely. You are a smarter man than I am. The moment he give me that, I publish it in all my documentation. I won't take credit away from the guy gentleman. He asked me. I said, absolutely, go for it. And then, of course, at that moment, I started getting a lot of customers who shoot the Carbon Express Medallion, the Brick McKinneys, the X10s, the target guys. I say, remember when you shoot 166 in the target, because that's what it's original for. Now think through it. you put your tungsten point, which is about 4 inches long, into your shaft. Where is your note?
Behind that.
Right. And then every time you break that point, your entire arrow note effectively
Changes. Yeah.
So now you have the whole dozen recut, redo. Do you know that a set of X10s with spin ring and tungsten point is about $1,000?
Whoa.
How many of them can you try to build right?
Yeah, right.
Now then, if you look at the 166, is there a way to make 166 shine? Well, I was very happy to tell you we granted 2 separate U.S. patents on the 166 insert system. It's called the arrow stamp system. What happened is that I now make an insert with the back, just like a hybrid insert. You can slide the 166 inner tube on the back. In the front, instead of a hole, is a stamp that sticks out with 2 O-rings. Now, you know what that does? It makes that part the strongest. Now you have a metal to carbon connection. Yes, I invented a whole new insert broadhead system. So
If I'm not mistaken, it was developed probably within 60 feet of where we're sitting right now a couple years ago.
2 years ago when we were in that booth, you and Dave talked about it. I said, yeah, why not? So I just pulled my computer, turned on the TurboCAD, and got it designed. It's sort of nice when you have that ability.
Yeah, yeah. So how does that fix the problem?
Oh, first of all, we have the weakest link become the strongest point. The only downside is that now all the AMO stuff no longer work.
Okay.
Because the front part is based on the 3mm dual O-ring hole.
Okay.
That means you got a stamp that is about 5mm long with 2 O-rings, and then you got the 3mm thread on it. So now your field point or broadhead have this hole that you can screw on top. Now, at the same time, we have the neck. The neck is the same as all our insert system with the reverse taper. Mm-hmm. Now, remember, when you do a 166 reverse taper, you're talking a whole thickness reverse tapered.
Yeah.
Now you're talking protection beyond belief.
Yeah.
Then with the shank coming down halfway, I minus the size, and then I put the carbon inner tube on it. Now you got the arrow concept on it now. So the front of the arrow is guaranteed to be straight. Now you go into a second challenge. You know, every single shaft based on the AMO standard has to have a hole in it. If you got stainless, you got a shank that after you minus the tube, you got a hole that is 0.09 inches, which is 90,000 shank. How do you put a hole in it? I have to sort of take all the things I know and say, oh, I can't drill. It's not possible, not on a 420 hardened stainless. That is 53 HRC. I mean, it's impossible to drill that. I finally decided, well, you know what? Let me see if anybody can do EMS, electromagnetic discharge. So I actually using electronics to discharge the metal and make that hole.
Wow. That's a serious process.
Well, most people, I mean, I feel myself privileged and lucky that I got exposed to all this technology. But when you do this, we make things possible. Now, yes, in a 166, if you do all of the above, it will fly. What the arrow concept in the 166 does is that instead of taking 23 yards to recover, now you take 12 feet to recover.
Which is extremely substantial.
Compared to a 9 feet of the 246 and about 7 to 8 feet on the 300.
So with this new system, does this make 166 attractive to people again?
It's viable, but you are limited to all the broadhead I made.
Ah, I see.
But for the target guy, it's perfect because now when you put different weight of fuel point, your note do not change.
Yeah.
That's the big deal.
Okay.
Because remember, every time you break the inner pieces to change the weight, and you recruit using a hot melt, your note moves back and forward.
Yep. It's never consistent.
In the case of Olympic archery, it's not that bad because you're dealing with some of the shelf shooters. The moment you go arrow rest, it is very, very critical.
Yeah, that makes a lot of sense.
Well, just before I jump into the higher size, do we have time?
We're at 52 minutes here.
Oh, well, then I better jump into the larger size. And a lot of people also do not know the archery well do not stop at 300. The moment you go to target well, is now you go into your 315, which is your 2364, your 93, your 24, which is like your X cutters, and your 25, 26, like your PS 26, and then your 27. But the 27 is not a 27. 27 is 270, 282, 83, 85, 88,000 of which now you look at 2764, which is 384,000
Wow.
of ID.
Yeah.
Because your wall gets thinner and thinner. The moment you go to insert in this class, technically you will not be able to find anything besides what the manufacturer make the shaft do. I would be happy to tell you, we at Firenock pretty much make everything for that. So you can learn more about this through our Firenock Component system, which is a database I wrote. It's based on 5 SQL Server. So you know when you pick the arrow manufacturer, you pick the shaft, then you pick all the component. It's not just a component. You click on individual component, you buy or you ask for the explanation of that component and what the benefit of it. I think that would actually, I'm old enough to understand education and knowledge is king.
Yep.
I think I'm one of the few guys who provided this information to everybody.
Yeah, I don't know anyone that's doing that.
But why not? I mean, you know, the whole thing is that the knowledge is benefit everybody. Yes, I make the stuff. But if you don't know how to use the stuff, it's pointless.
Right, yeah. So is that component system, the database for every diameter shaft, or just the...
Technically, every single shaft all the way back to the Eastern Excel that came out in 2003 onwards.
There's a lot of stuff in that.
Pretty big database.
Yes.
So say I have the Sirius Apollo arrow.
Yes, you click Sirius and click Apollo. If it's 166, because in 166 you will tell you to specific shaft diameter, because the outsert to fit it will tell you which one will fit that exactly.
Okay.
And then will
Gives
tell
you
you
like
which,
a big drop down of this is the knock you'll use. This is the the outsert per spine
Sure.
you'll use. It's pretty slick.
Yeah, that helps a lot. That takes the guessing out of it.
Yes.
There's a lot of. I mean, I think whitetail hunters probably not the upper echelon of whitetail hunters, but the average
General, yes.
like they're just gonna buy something and whatever comes with it, they're just gonna accept that for what it is. So if you go to this system until you have the ability to say, okay, this is what I'm getting and this is why I'm getting it, because you have the.
Exactly. I think people need to think about it. Just like, think of the archery world like a car world. If you say, I'm going to have a Sienna, okay? When you go and buy archery, you don't say, I have a Sienna CE, S, EX, limited, platinum, limited plus. You got CE.
Yeah.
That's it.
Yep.
So when you buy a single arrow shaft, you got this insert that come with it, you got this knock that come with it, you can maybe do some things and cut.
Yep.
All this stuff that exploit the ability of that Sienna is not available to you from the manufacturer.
Right.
In the case of me, if you get the CE, I'm gonna help you to put it in the XLE Limited all-wheel drive. Yes, you're gonna pay for it. There's no
yeah.
doubt.
Yeah.
But the thing is that I always have certified and trained dealers that will help you.
Do you recommend most people that want to shoot Firenock components and stuff to go to a dealer and
Absolutely.
have them build it?
First of all, you need to understand, all my certified and trained dealer all went through at least 6 hours of video training, if not in-person training, 2 hour practical, and then 1 hour test. And on top of that, I mean, starting 2021, they have to go through to build 2 different arrows and send it back to me. I will cut them open, break them, and see what they did wrong or right.
Sure.
Because there is so many minute things that people don't do right until they do it themselves. I mean, most of the dealers say, oh, like Vital Limit, they are comfortable with building crossbow. And Jeremy is super comfortable building 204. And I got a gentleman in Indiana that's superbly comfortable with building 166 because that's all the customer use.
Sure.
And that's how they did it. I mean, it's not that Jeremy can't build 166. It's that's not he built a lot. Just like you don't bring your BMW to a Chevy dealer and say, fix it.
Yeah. So, what about 204? Like, why did you hone in on it? Is that because of what you're shooting?
No. Yes, I do shoot 204, but when I first started this about 6 years ago, the 204 was just kind of coming on the scene. You know, the Rampage was out.
Yep.
And Black Eagle was high on those. And just over time, that's, you know, I can go back and look through all of my build sheets, and I would say 90% of them are 204. That's just what the folks wanted.
Sure.
You know, Ohio hunters are pretty, they lump together and they like to shoot a lot of the same stuff, what I find.
Yeah.
And the 204 is definitely one of the shafts that are a sought-after shaft that I've seen.
What do you think makes the 204 diameter attractive to whitetail hunters?
A lot of the hype from the industry.
Yeah.
Smaller diameter, better penetration, more power, but I can build that into any shaft. I could build that into a 246 shaft.
That's the point I wanted to get at there.
Right.
Was like, if
it's a lot of media hype that 204, 166. This is the only route you should be shooting because.
Have you converted anyone from 204 to 246?
Yes, I've converted 166 guys to 246.
What was their reaction? What was their initial holdup, and then after they shot the arrow, what was their initial reaction?
Initial holdup was, there's no way.
Yeah.
It's
It's a dinosaur.
yeah. I'm the gimmick,
Yeah.
not the industry.
Right.
I says, how about this? I'll build the shaft. I'll build a cheap shaft. I'll put the good components in it. I'll send it to you. You shoot them. You don't like it. You send them back. I'll give you your money back.
Okay.
I never got the opportunity to hand any money back to a customer. So they really like it. You just have to be willing to open your eyes and ears rather than having the tunnel vision or the horse blinders on the side of your face, to just open your horizons to the new things that are out there, to the technology and not the norm.
So technically speaking, the 246 is easier to get better performance out of it than the 204.
Yes.
Okay. So like even myself, I'm having a hard time sitting here. I'm like, I don't know if I can shoot 246 arrows.
Well, let me just put it this way. This year, all my customers who trusted me forever, you guess what I built for them?
300.
All 300 size.
Yeah.
So he's
300,
building
400.
one size bigger.
Yeah.
You know, he's building essentially, as the industry knows it, as a target shaft
Yeah, for hunters,
for hunters.
whitetail guys.
Right.
Think about it. If money is on the line for everybody, 10,000, 20,000, if 166, 246 is really that great, they say, oh, you need penetration. Remember, if the arrow don't stick the target, the point don't count. You think when you got 20, 30, like somebody who got a few sponsorship with a $50,000 check hanging in front of them, if the 204, 166, or even 246 is better than what they can absolutely guarantee to shoot the 11 ring, you think they wouldn't be using those?
Right. Yeah.
Just think about it for a second. When money is on the line, your livelihood to feed your family is on the line, what should you be using?
Yeah.
Just think about that for a second.
Yeah, that could be like you were talking earlier, those 1 or 2 points, that could be the difference between $10,000 and $2,000.
And people want to say, well, I'm shooting an animal. If I hit the shoulder bone, well, come on. Your heart and shoulder bone is over 4 inches away. And those guys are counting millimeters. Did you cut the line with a 2764? What are we talking here?
Yeah. Yeah. The only thing that, I mean, a deer can move, a target can't.
Right? That's exactly. If you are that precise on it, and furthermore, the moment when we finally go into the point of the veins, I would tell you, the moment you shoot the correct arrow, deer don't move. Because if they're moving, you're shooting a running animal. If you're that good, you shouldn't be worrying about that.
Yeah.
And we do have to clarify one thing. It doesn't matter what arrow you build. You're not going through a shoulder joint of any animal.
No, yeah. The ball.
You might be
yeah.
able to nip, the shoulder blades and be fine. I mean, I've had guys that come to me and they've blown through both bottom parts of the shoulder blade.
Yeah,
they
the
didn't hit the heart of the shoulder.
The scapula on a whitetail
Exactly.
is pretty thin.
Yes.
Mm-hmm.
Yeah.
So the scapula is fine, but the joint,
Yeah, no one's going
I don't
through
care
it.
what
Yeah.
you build, your plan B arrow is going to fail.
Right, yeah. So real quickly before we wrap this up, I think it's important for you to take a couple minutes and explain the point that you made about the when you have a field tip on your arrow and you shoot it into a target, you penetrate better. The moment you put a broadhead on it, it's all the same. So kind of explain that process a little bit.
Well, very simple. It's diameter. Correct again. The moment you put a 166, you usually put the field point on it, just like a target point. Unless you use my outsert, then you put an 8mm point. Just like Eastern, when they come up with the axis arrow, they go into 7mm point. You know why? Because it penetrates better. It's smaller.
Yeah.
But the moment you hunt, you all use broadhead. It doesn't matter what size shaft you use. The broadhead is the same on every single arrow.
Sure. Yeah.
So what does thick and thin have nothing to do with it? Nothing.
Because when you shoot the animal, the hole is created by the broadhead, and the arrow no longer is touching anything inside of that hole.
People say, oh, well, you glide through the blood better. I say, how many seconds you think that's going to happen?
Oh, it's like, yeah.
The grabbing of the arrow, actually, in some cases, you want the arrow to froth. You want the brine to froth the blood to go through. You want the arrow to not go straight in. You want it to spin as it move in, because then you do a spiral cut.
We're getting into a big topic right there.
Yeah, I think that explains, that debunks that marketing myth that the thinner diameter shaft penetrates better on a target, on a whitetail. That's gone. That's mitigated from the broadhead, because the broadhead's wider. It's creating a bigger hole, and that the arrow does nothing at that point. It doesn't. It doesn't increase or decrease penetration.
As a matter, the thinner the arrow, the worse it penetrates, because the arrow is still flexing.
Right.
That means the energy is no longer focused. As you know, anytime you flex, just like I say, if you want to nail, say, a 30-inch nail into the ground, the thicker the size of the same weight, the better off you are. There's no way around it. I mean, pure physics. Because, see, the memory effect, the float, the oscillation of the shaft on the thin one, and because the memory effect, just like when you throw a thick arrow, you hammer it, you shake a little bit, you stop. Throw it on a thin arrow, you go shake, 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 shake. Well, that whole process, the energy is consumed in the shaking process. And also, remember, when you shake the arrow, the energy is not going straight down. The resulting factor is actually backwards. Just like when the fish goes swing left and they swing right, the force going that way, but the resulting force is this. But remember, it's only a resulting force. Majority energy is still lost in this part.
Sure. Yeah, I think that covers it and clears it up. So for people that are listening to this that are still like, I can't shoot 246 or 204 or 166 or 300 or whatever, at the moment you put a broadhead, because most of my audience are whitetail hunters, so that's what I'm trying to really.
Well, let me bring it back. If you have the know-how, you have the equipment, I would tell you, Jeremy or any of my certified and trained dealer can build any size arrow to do the job. The fact is that if everything is equal, including money, 246 will always be cheaper, higher performance. If you absolutely need the 160, can we do it? Yes. You're going to put a lot more effort, a lot more money to make the 166 shoot as good as a 204. Or even a 246, or even a 300.
Yeah, so at that point.
Right. So if you are not really totally in tune with building, you're better off using 246 or 300. The moment you say, I want that, I love that, I want to have it, answer says, you can have that too. You just need a lot more knowledge, effort, and money to get it right.
Yeah. So, Jeremy, last question for you. Do you prefer to build 204?
It doesn't matter to me.
Okay.
It's all an arrow shaft. Another reason, I was just sitting here thinking when Dorge was talking, the 204 is so attractive because there's so many options.
Oh,
I can go with a heavy wall inner carbon. I can go with a light wall inner carbon. I've got aluminum, stainless, titanium. You know, where the 246 you do have two different types of aluminum. You do have brass and you do have stainless.
Yep.
But my options with the 204 are endless.
Yeah.
I can make
two different inner tubings.
I can make some crazy
custom
configurations that will knock people's socks off. So,
do you fear that as the industry moves towards the 204, 166, that 246 and 300 components are going to phase out?
No.
Okay.
No.
All right.
300 will always be here
because of the target.
For the
crossbow.
Crossbow.
Yeah.
All your crossbow.
Yeah.
Well, the vast majority of your crossbow bolts is a 300 ID shaft. And 246 has just always been the industry standard.
Okay.
Just like, I don't know, 20 years ago it was a 2213. If you was a hunter, that's what you was running.
Yeah.
A 2213, a 2217.
Yeah.
So.
All right. Yeah. Well, I think we'll leave it at that. We've been going for an hour and 7 minutes here. Next episode, what are we going to hear from?
Well, we'll dive into the most technical aspect of the entire arrow. Thanks.
I can't wait for that. I need to do some studying up before we have that conversation. So, all right. If you guys enjoyed this episode, please check out firenock.com. Read more about what Dorge is offering, and check us out here at the Deer Gear Podcast.
By the way, you can find Jeremy on X-Ring Custom, and if you want to find out his your email address is.
It's xrcarrows@gmail.com, and the website is in the works, probably within 2 months.
All right, guys, let's have a good show today.
Thanks.
Thank you.